So today we're going to focus on the last of the three different types of probabilities, and that probability is known as binomial probability. So let's talk about what a binomial experiment is first. And a binomial experiment consists of n number of independent trials in which there can only be two outcomes, either a success or a failure. The probability of success is always going to be denoted as P, and the probability of failure is always going to be denoted as Q. So here we've got the probability of success is P, and the probability of failure is Q, and that's also going to be 1 minus P. All right, and that makes sense because we know that all probabilities should add up to 1. All right, so let's look at these experiments. All right, what is the probability of success that when you're randomly selecting a month 30 times, you pick January? So when you're randomly selecting a month 30 times, you pick January. Well, we know the probability of picking January in a year is 1/12. So that's our p-value. Whereas Q is our failure or not January, which is going to be 11/12. Okay? You try to do the next one on your own. Okay, so if you are going to randomly select a card 100 times, right, what's the success of picking a heart? Well, we know that's going to be 1/4. All right, there's 4 suits, one of them is a heart. All right, what's the failure? It's 1 minus 1/4, which equals 3/4. Okay? All right, so that brings us to what binomial probability is. All right, what is binomial probability? If a binomial experiment has n trials in which P is the probability of success and Q is the probability of failure, then the binomial probability that there will be exactly R number of successes is found by doing NCR times P to the R times Q to the N minus R. All right, so let's look at that with a problem. Mark tosses a coin 25 times. So right away, we know that the number of trials, N, is equal to 25. What is the probability that it lands on heads exactly 7 times? So it tells us that R is equal to 7 because that's considered successful. Okay, that's how many times we want a success. Now we have to determine what P and Q are. P is the probability of success. Well, we know that P is going to be 1/2. That's the probability of landing on heads. And in this case, Q is going to be 1/2 also. The probability of not landing on heads is 1/2. So we're going to put it into the formula, all right? And we're going to do 25 C7 times 1/2 to the 7th times 1/2 to the 25 minus 7. And if you figured this out in your calculator, this would equal 0.0143 or 1.43%. All right, let's do number 2 together. The spinner below is spun 10 times, all right? So we know the number of trials is equal to 10. What is the probability that it lands on red exactly 6 times? So the success is going to be 6 times, so R equals 6. All right, and then let's talk about the probability of success. The probability of success is 2/6, red. So that simplifies to 1/3. The probability of failure is 1 minus 1/3, which is equal to 2/3. So you're now going to plug it into the calculator, okay, and follow the formula. 10C6 times 1/3 to the 6th times 2/3 to the 10 minus 6. All right, and you'd plug that into your calculator, and you'd get 0.0569, which is 5.69%. All righty, I would like you to do numbers 3 and 4 now on your own. Okay, so Kate took a multiple choice test with 4 choices for each question. If she guessed the last 5 questions, what is the probability that she got exactly 3 questions correct? So N is going to equal 5 here, and R is going to equal 3. Now, what is the probability that she guesses them correct? Well, that's a 1 in 4th chance, which means Q is going to be 1 minus 1/4 equals 3/4. So in this one, we're going to have 5 combo 3 times 1/4 to the 3 times 3/4 to the 5 minus 3. And we'd plug that in, and we'd get an answer of 8.79%. Okay, Chad randomly chooses a card from a standard deck 30 times. So N equals 30. What is the probability that he gets a diamond exactly 4 times? R equals 4. All right, probability of getting a diamond is 1 in 4 because there's 4 suits. So failure will be 3/4. So 30 combo 4 times 1/4 to the 4th times 3/4 to the 26. And we get 26 by doing 30 minus 4. And if we did that, we would get an answer of 6.04%. So this is an example of finding binomial probability when you know the exact number of successes. But what happens if you're given the quantity of at least or at most? So let's look at examples like that. So let's look at number 9 here. Kyle tosses a coin 10 times, okay? So once again, the number of trials is 10. What is the probability that he gets tails at least 8 times? So in order to be successful, it says at least 8 times. Well, that means that it could be 8, it could be 9, it could be 10. So you're going to have to do that for each one. We know for him to get tails, it's going to be 1/2. And the failure of getting heads is going to be 1/2. So you're going to do this 3 different times. 10C8 times 1/2 to the 8th times 1/2 to the 10 minus 8. And then you're going to do 10C9 times 1/2 to the 9 times 1/2 to the 10 minus 9. And then you're going to do 10C10 times 1/2 to the 10th times 1/2 to the 10 minus 10. And when you do this, this one is going to equal 0.0439. This one is going to equal 0.0098. And this one's going to equal 0.0010. You're then going to add these all together and get 0.0547, which we know is 5.47%. So when you're not given the exact number and you're given at least or at most, okay, you're going to have to find each one of the binomial probabilities individually and add them all together. I'd like you to do number 10 on your own now. All right, so let's do number 10 together now. Carol randomly chooses a day of the week 6 times. So our N value is 6. That's the number of trials. What is the probability of choosing Tuesday or Thursday at most 3 times? So at most means never, once, twice, or 3 times. All right. Now, what's considered successful is choosing Tuesday or Thursday. So that's 2/7. So then 5/7 is considered the failure. So you're going to have to fill this formula out 4 times. All right. 6 combo 0 times 2/7 to the 0 times 5/7 to the 6 minus 0. Okay? And then 6 combo 1 times 2/7 to the first times 5/7 to the 6 minus 1. 6 combo 2 times 2/7 squared times 5/7 to the 6 minus 2. And then 6 combo 3 times 2/7 to the third times 5/7 to the 6 minus 3. If you found each one of these individually, this first one would be 0.1328, 0.3187, 0.3187, and 0.1700. And if you added these together, you'd get 0.9402, which is a 94.02% chance of picking Tuesday or Thursday at most 3 times. All right, now it's time for you to work on your worksheet. Have a great day.